oxygen atoms. Ozone has a particularly useful characteristic. It can absorb large amounts of ultraviolet light. So where is the ozone? The ozone layer is in the stratosphere, thinnest at the equator and thickest at the poles. The ozone layer absorbs the UV light to stop it reaching deeper into the Earth's atmosphere. It protects us from the damage the sun, or UV light, causes, such as skin cancer.
My skin really hurts. I think I'm getting cancer.
Eye damage. And other damages to the human body and animals. The problem is that us humans are selfishly emitting CFCs, or chlorofluorocarbons, causing a rapid depletion of the ozone layer. Man-made CFCs include cleaners, coolants in the refrigerator and AC, propellants and aerosols. These halogen atoms act as a catalyst, causing the degradation of ozone. So Hannah, where is this problem the worst?
The problem where ozone depletion is most prevalent is in Antarctica. Because the ozone layer is depleting, more ultraviolet radiation can pass through the atmosphere, which causes the glaciers to melt and animals that live on these glaciers to die. Some of these animals include polar bears, which are almost extinct, penguins, and seals. It is worst in Antarctica first because strong winds blowing around the continent floor, known as the polar vortex, isolates the air over Antarctica from the rest of the world. By the time spring arrives and the sun comes back after the long polar night, the ozone levels are severely depleted around the Antarctic, causing the ozone hole. Unfortunately, there then follows a particularly long period of high sunshine and long days, just to make the effect of the ozone hole worse. Natalie, now back to you.
The only way to stop the formation, growth, and spread of the ozone thinning is to reduce the production of these chemicals that cause the depletion of ozone. The only huge attempt to address this problem was in 1987, when the Montreal Protocol was signed by many nations to agree to reduce their emissions of CFCs to a half by 2000. Nowadays, potential problems come from nations that do not see the reduction of CFCs to be a priority, and also from the huge quantity of refrigeration and air conditioning systems in the world that still contain CFCs. The problem is far from settled and is under investigation by research teams all over the world. The latest estimates are that as long as production and release of CFCs is regulated properly, global ozone levels should recover by 2050. This is only if we, as a community and people, make an effort to stop producing CFCs. Now, how are these solutions working? And what are some potential solutions that haven't been tried, Hannah?
Efforts to reduce CFCs today have benefited the ozone layer but have not saved it. Future plans to reduce ozone depletion could include paying or rewarding businesses to stop producing CFCs. This could affect the ozone layer on a world scale since businesses and factories are everywhere. In 1928, scientists first synthesized chlorofluorocarbon, or CFCs. In 1973, scientists detected CFCs in the atmosphere. In 1975, S.C. Johnson announced corporate phase-out of CFCs as aerosol product propellants. In 1978, the U.S. banned non-essential uses of CFCs as a propellant in some aerosols like hairsprays. Canada, Norway, and Sweden follow with a similar ban. In 1981, the UNEP developed a global convention to protect the ozone layer. In 1985, the British Antarctic Survey Team discovered Antarctic ozone hole, 7.3 million square miles, marking the first evidence of stratospheric ozone depletion. In 1987, 24 countries signed the Montreal Protocol on substances that deplete the ozone layer. In 1994, the U.S. eliminated production and import of halons. In 2000, Japan Meteorological Agency reports the hole in the stratospheric ozone layer over the Antarctic as at its largest to date, more than twice the size of Antarctica. In 2006, the ozone hole is reported to be the biggest ever, exceeding that of 2000. In 2010, all developed countries reduced consumption of HCFCs by 65% from baseline levels. 2060 to 2075 is the earliest time frame projected for the ozone layer to recover.